Hi everybody! So it's about time that I put up a new video, and tonight we're going to talk about combustion because fire is something that everybody enjoys. So combustion is a reaction that produces fire, more or less. That's a very simple way of putting it, but it's a way that people can kind of understand. Now combustion is what we call a reduction oxidation reaction. Now reduction and oxidation are things that involve the movement of electrons. Electrons, as some of you might know, have a negative charge. So like one electron is -1, more or less. So reduction is when an atom has a addition of an electron, right? So it's +1 electron, so it is -1 charge, right? So that's the big thing. Like it's reducing the number of charge that is on that atom, right? So if it's like at a neutral state, it'll go to -1, right? Makes sense? Okay. Oxidation is when you have the removal of an electron. So it has a +1 change to its charge. If it's at a neutral state, it'll go to +1. Like sodium is oxidized pretty easily. It goes to a +1 state, more or less all the time. But combustion is a redox reaction where both are happening at the same time. In combustion, we turn to the board now. Here we go. Combustion, there it is, has kind of a regular form where it is a fuel source, signified as X. The fuel source is usually involving carbon. It's usually a hydrocarbon. It has carbon, oxygen, and hydrogen for the most part. But we also have oxygen gas, O2, which is why if you remove oxygen from a fire, it no longer burns. It needs oxygen to burn. But at that point, it yields carbon dioxide, CO2. We hear about this a lot. It's a gas. If it's a solid, it's dry ice. It doesn't really exist as a liquid. But in this case, it's gas. Water vapor. If you are heating up something in a saucepan on a stove, you may notice that while the saucepan is heating up, you know, it's just being put on the stove, it gets kind of a condensation ring around the bottom. What that is the water vapor from the fire cooling on the saucepan and condensing, becoming liquid water. And you notice that doesn't happen once the saucepan is heated up. That is because the saucepan is now warm enough where the water can't really condense on there. But you have the water vapor and whatever remnants of the fuel there exist. For some fuel, there is no remnant. Methane, CH4. There is no remnant. That X does not exist. You just have CO2 and H2O coming off. But sometimes not all of the O2 reacts properly, or there's not enough O2 present, or anything like that, and you just get isolated carbon atoms. Well, these isolated carbon atoms bond together, or they form together, either way, and you get groups of carbon, and that is the soot and ash and such that comes from fire sometimes. Oil lamps, you know, it was a sealed off lamp, right? You limited the flow of oxygen, you got a lot of soot build up. Well, what that is that's carbon that didn't react fully. It didn't form the CO2, it just straight up formed solid carbon. So that is the chemical portion of fire. Where the light comes from is, as some of you may know, electrons when they go from a state of excitement, they're very excited, they have a lot of energy. When they release that energy, a lot of it comes off as light, depending. So you get the red light when a little bit of energy is being released, orange when more, yellow, and so on and so forth. Blue is probably the highest energy. You don't really see purple fire. Purple light would be even higher energy than blue, but it doesn't really happen. But that is where the light portion comes from, and that's a lot of what we use fire for, the light and then the heat that is given off from the reaction. This reaction is exothermic. Exothermic means that it gives off energy as it progresses. So that's kind of touching on exothermic reactions and reduction oxidation reactions and fire in general, and combustion. Combustion, as I said, is a redox reaction, and more or less all combustion reactions occur in that mode. Looking back at the board, the X for the fuel, it does change every so often, but for the most part, it is a combination of carbon, hydrogen, and oxygen, and it kind of just ends in that result. So that is your current update on the world of science fueled by ethanol. And I hope you have a good however long until I see you next. Take care. Bye.